This is Sindhuja. I am presenting the topic Flexible Lithium Ion Planar Thin Film Battery. Here is the outline of my presentation. First, introduction, working principle of lithium ion battery, advances in flexible lithium ion batteries, problems associated with these flexible lithium ion batteries, process flow for a flexible lithium ion battery, characteristics, conclusion, and differences. Introduction. Flexible energy storage devices are increasing attention as they are showing unique promising advantages such as flexibility, lightweight, and so on. These properties enable them in the applications of portable, flexible, and even wearable electronic devices. In this figure, we can see several typical examples of designed flexible energy storage devices and their potential applications in flexible electronics, printable electronics, integrated systems, wearable electronics. Working principle of lithium ion battery. When the battery is being charged, the lithium ions migrate from the lithium rich cathode and move into the anode. In this state, we will absorb energy that can be stored. If the battery is turned on during charging, the lithium ions will move back to the cathode and electrons will move from the cathode to the anode, and a current between the two electrodes is created. When the battery is not being charged, then that state is discharging state. The lithium ions move from the anode to the cathode and electrons will travel from the cathode to the anode. The time it takes for the ions to completely discharge is the current life of the battery, and when all the lithium ions have returned to the cathode, the battery will run out of power because the electrons will not migrate if there is no lithium ion movement. Then the battery will need to be charged again. Advances in flexible lithium ion batteries. In recent years, advances in flexible lithium ion batteries explore development in two ways. One is exploration of new types of materials for battery electrodes such as carbon nanotubes, graphene, and another is thickness reduction of non-flexible materials to undergo strain levels below typical levels required to induce fracture. Strain equal to T by 2R into 100%, where T is thickness of material under strain, R is radius of curvature. The problems associated with them are it requires rigid substrate to support the thin films during deposition process. They are time consuming processes and their outcome is poor. Here is the outline of my presentation. First, introduction, working principle of lithium ion battery, advances in flexible lithium ion batteries, problems associated with these flexible lithium ion batteries, process flow for a flexible lithium ion battery, characteristics, conclusion, and differences. Process flow for a flexible lithium ion battery. PDMS, polydimethyl siloxane, is a support substrate of a thickness of 100 micrometers which is prepared by spinning at 500 speed for 30 seconds on the silicon substrate, and it is cured at 100 degrees, which we can see in the first figure. PDMS spinning on silicon substrate, and after that a second layer with a thickness of 10 micrometers of PDMS is spin coated on top of the first PDMS layer at 1500 speed for 30 seconds, giving a very thin layer of PDMS, which we can see in the second figure. Second PDMS thin layer spinning. After that PDMS spinning, the die with the lithium ion battery stack is placed upside facing the PDMS thin layer and cured at room temperature for 24 hours, which we can see in the figure die transfer on PDMS substrate. After PDMS curing, the exposed silicon substrate can be further processed into a xenon difluoride, which we can see in the last figure. And we will continue etching of silicon to allow the complete removal of all surface roughness as shown in the figure. The silicon dioxide insulating layer acts as a stopping layer to prevent further exon difluoride etching to take place in another parts of the stack. Due to large selectivity of xenon difluoride etching, it may occur. Charge discharge characteristics for our cell. Desirable flat voltage curve is observed for a selected voltage from 4.2 to 3 volts in both bulk and flexible batteries. Battery is charged with a constant current of 6 microamperes to reach a charge cutoff voltage of 4.2 volts. Discharge characteristics for flexible lithium ion battery at different discharge rates. The capacity is less for higher discharge rate. We can see in the figure from the figure that the capacity is decreasing as the discharge rates are increasing. Conclusion. We can observe that our lithium ion battery has the advantages which includes high yield production, ease of handling, flexible samples. And from the table we can observe our work has the discharge capacity higher compared to the other works. I have used these references to my presentation. Thank you.